So starting from the beginning, we say that statistics consists of collecting, organizing, and summarizing data, then analyzing in order to make inference about the population. So the first part of statistics is descriptive statistics, and the second part is inferential statistics. We are learning probability as a bridge to get from descriptive statistics to inferential statistics. Chapter 6 is what will really portray that bridge from the two. So, in order to make inference about the population, we say that we need a sample which is representative of the population. We call it a random sample. The process of getting a random sample is essentially a random experiment, because you have a large population and you want to randomly select a portion of it. So that is a random experiment. So we can consider a random sample as an outcome of a random experiment. So maybe I can write that. Observe that a random sample is an outcome of a random experiment. So by associating to each random sample, the specific statistic we want to record here that what we call a statistic is a measure from the sample, like the sample mean, sample variance, sample proportion. Example, sample mean. We define a random variable because a random variable associates to outcome of a random experiment a number. We define a random. Which is called a sampling distribution. This process is called sampling distribution. Example. If the statistic is the sample mean, the distribution, then X bar is called the sampling distribution. Of sample mean. The sample proportion is P hat equal to X over N, where X is the number of success. Success here will mean the characteristic we might be interested on those individuals. Where X is the number of success. And N, the sample size, or the number of trials. For example, if we have a population of 5,000 people and we randomly select 50, We may want to know what proportion of those 50 has a flu. That is proportion. We count the number of people with a flu and divide by the total. That's the meaning of this sample proportion. So P hat is the sampling proportion, sampling distribution of sample proportion. So we can observe here that we are now defining a random variable from descriptive statistic, looking at the statistic we were computing in the sample summary as our random variables. We have, for example, the sample mean, the sample variance, sample standard deviation, and the sample proportion. So we are going to look at two of these distributions, the sample mean and the sample proportion. More focus on the sample mean. So, mean and standard deviation. Let's call it standard error. The standard error is the standard deviation of the mean. So recall that the sample mean is the sum of x over n. By x over the sample values. Because the sample is a random sample, x could be any number of the population. X could be any member of the population because we say a random sample is a sample in which every member of the population will be power is representative of the population. For that reason, we will say that so the mean of x equals to E of x is equal to mu, the population mean. And the standard deviation of x equals to sigma, the population standard deviation. So when we define x bar as sum of x over n, x is any value from the sample. But we go back to the original way we got those values because we pick them randomly from the population. Meaning that that x could be any member of the population, could be value associated to any random member of the population. So it represented the population as a random variable. So generally, you will hear people in statistics and probability calling the random variable x a population. So now, what will be the expectation of x bar? The expectation of x bar will be mu, the population mean, And the standard deviation of x bar will be sigma over square root of n, where sigma is the population standard deviation. So let's show why we have this. Because E of x bar is E of sum of the x over n. By the linear property of expectation, this is 1 over n, E of sum of the x. By the linear property, remember we say E of ax plus b is ae of x plus b. So E of anything is any factor of that thing out times E of it. So we took 1 over n, which is here, out here. We also say that the expectation of the sum is the sum of the expectation. That is, if we have E of x plus y, that's the expectation of E x plus y, is E of x plus E of y, is the sum of the expectation. So the sum, expectation will split the sum. So for that reason, this one will now be written as sum of E of x. But E of x, for any x, is mu. And we are going to add mu to itself n times. So this will be n mu. Now to find the standard deviation, we will first compute the variance. The variance of x bar is variance of sum of the x, sum of the x over n. This is x bar. And we say that the variance of ax is a squared times variance of x. So we are going to take this 1 over n out. And when you take something out of the variance, you square it. Variance of sum. Because members of the samples were randomly selected, the x values are independent. And when you have independent random variable, the variance of their sum is the sum of the variance. This will be sum of the variance, which is 1 over n squared, and there will be n of them, which is sigma squared over n. So the standard deviation is square root of sigma squared over n, which is sigma. So that's what we have on this slide. So essentially what we are saying is that if you have a population of mean mu and standard deviation sigma, whenever you take a sample, a random sample from that population, the distribution of sample mean that you define as mean, the population mean mu, and standard deviation, the population standard deviation divided by square root. We will do the same thing for the sample proportion. Just add it there. It's not on your PowerPoint, but it is not difficult as well. Computing mu p hat and sigma of p hat. Mu p hat is E of p hat, which is E of x divided by n. That's the proportion. Is the number that you want divided by the total. X is the number of success, which is 1 over n p of x, which is np over n equals to p. So the mean of the random variable sample proportion is the population proportion. So what does this actually translate to? What it means is that the expectation of the sample proportion is the population proportion. The expectation of the sample mean is the population mean. So meaning that when you are working with a sample proportion, you are expecting to get to the population proportion. And the variance is variance of p hat, which is variance of x over n, which is 1 over n squared, variance of x. Remember that x here is the number of success, n is the number of trial, p, the population proportion, is the probability of success. So the variance of x is npq. Remember that. npq, that's what we said on Tuesday, over n squared. This is pq. So the standard deviation is equal to square root of pq. This part is not on the PowerPoint. So we use sample statistics to estimate population parameters. For example, we know that the probability of getting a head when you toss a coin is 1 over 2. When you toss a coin 20 times, the proportion of heads you get is called the sample proportion. So you are using that sample proportion as an estimate of the population proportion. Maybe you will get a number like 9 over 20 when you toss a coin 20 times. You will get 9 over 20, 9 heads out of 20. That is an estimate of the actual probability of success, which is the population proportion, and which is half. So statistics consists of using sample to make estimates about population. And the way out of it is through this sampling distribution of sample statistics. So X bar is the sampling distribution of sample mean. P hat is the sampling distribution of sample proportion. S is the sampling distribution of sample statistics. So the statistics that we computed at the end in chapter 3, at the beginning in chapter 3, those statistics are now called random variable with a distribution that we are calling sampling distribution of those statistics. So the question we generally ask ourselves is, can we estimate the probability that a sample mean is within a certain range of value without actually computing the sample mean? For example, I want to determine if the sample mean, if I sample 50 students, will the average age of those 50 students be between 19 and 22? That's the question. I sample 50 students and I want to estimate the probability that their average age is between 2 and 5. That is what we do with the sampling distribution of sample, either mean or. So the big question we want to answer in chapter 5 is, what is the nature of the distribution? What is the nature of the sampling distribution of sample mean, for example? What is the nature of the sampling distribution of sample proportion? Central limit theorem. This is chapter 5. If X, the population, if X is normally distributed, then X bar is the sampling distribution of sample mean, the sampling distribution of sample mean. I don't have to be writing that all the time. Then X bar is approximately normal. So the sampling distribution of sample mean is approximately normal if the population is normally distributed. In general, if the sample size is large enough, for this class, we will consider large enough when it is at least 30, when the sample size is at least 30. But this decision is generally made depending on the nature of the sample that you get. If your sample has a histogram that is too skewed, you might want to increase the sample size to about 50 to decide that the sampling distribution of sample mean is approximately. In general, if the sample size is large enough, then X bar is approximately normal. So this is actually the content of the central limit theorem. The central limit theorem is to give us the characteristic of the sampling distribution of sample mean when the sample size is large enough. Let's look at this example, which will help us to make the connection between 6.1, 6.4, and 6.5. Suppose a team of biologists has been studying with 5-year-old children fishing. Let X represents the length of a single trout taken at random from the pool. This group of biologists has determined that X has a normal distribution with mean 10.2 inches as standard deviation, sigma equal to 1.4. So in each of the problems that you will encounter in this chapter and henceforth, you want to always record the mean and the standard deviation of the population. What is the mean and standard deviation? What is the mean of this population? 10.2. The standard deviation? What is the probability that a single trout taken at random from the pond is between 8 and 12 inches? Fine. Here, the random variable X, which is the length of the trout, has a normal distribution. So we can use the normal distribution from your calculator to do this. If you don't have a calculator, and I will expect everybody to have a calculator, you will have to do this manually. So while you are working that with your calculator, I will be busy showing how to do it manually, just to keep myself busy, because you should all have a calculator. Otherwise, we won't be able to complete this course. The time that we have is not enough to do all these computations. But yet, because it is a mathematics Math 2015, we want to know how to do it manually To do this manually, knowing that it's a normal distribution, we convert it into standard normal. Mu H minus mu over sigma less than Z. Mu is 10.2, which is equal to probability of 8 minus 10.2 over 1.4. Remember, you go to second function distribution normal CDF. When you do this, you get probability of minus 1.57. Then you are supposed to read this from the table. But you can use your calculator. Anybody has trouble using calculator? Just let me know. Then you go to second function, distribution. Anybody has the result? Normal CDF, 8, 12, 10.2, 1.4. Yes, anybody? .8, 426, let us say 0.84. This is the proportion of trout that measure between 8 and 12. 84% about. Now the next question will be, what is the probability that the mean X bar of 5 trout taken at random is between 8 and 12 inches? The next question, we want the probability that 8 is less than or equal to X bar less than or if n equals to 5. So the mean for X bar, the standard deviation for X bar is equal to standard deviation divided by square. So what is this? This is 3. So because this is now about the mean, we will change the standard deviation by dividing it by square root of 5. Now we have the standard deviation for the sample mean. The mean remains the same. So we have the probability that 8 is less than or equal to X bar, greater than or equal to 12. We don't need to do this. 8 minus 10.2. Can you use your calculator to do this? Anybody has an answer? We're doing essentially the same thing. Now, the standard deviation is normal 1.4, which is 0.6. Pardon? So if you are asked to find the probability for a single value, you use the regular mean and standard deviation. But once you are asked to find the probability for an average, then you adjust the standard deviation by dividing it by square root of n. One more example. A certain strain of bacteria occurs in all raw milk. Let X be in millimeter of milk. The health department has found that if the milk is not contaminated, then X has a distribution that is more or less mound-shaped and symmetrical. The mean of X distribution is mu equals to 2500, and the standard deviation is sigma equals to 300. In a large commercial dairy, the health inspector takes 42 random samples of milk produced each day. At the end of the day, the bacteria count in each of the 42 samples is averaged to obtain the sample mean bacteria count X bar. We want to write down the mean. What is the mean? $2,500. And the standard deviation? What's the sample size? Assuming the milk is not contaminated, this is the distribution of X bar. To determine the distribution of X bar, you have two things. Either you check if the population is normally distributed, or is the sample size large enough. So once we have large enough sample size, that is, for example, here we have 42, is larger than 30. So that's enough for us to say that the sample mean here is approximately normal. So our question is, assuming that the milk is not contaminated, what is the probability that the average bacteria count for one day is between 2350 and 2650? We need to know what is the mean of X bar, which is the same as sigma X bar is sigma of the square root of n, which is 300. So you can use your calculator. you can either do it manually, which I will encourage you to do because now the freedom to use your computer or you use your calculator. So, anybody tell us what the probability should be? Second function, distribution, normal CDF. Practice using my calculator. Change to this distribution. So what is the probability? So when you have a question in chapter 6 about the probability for a normal distribution, ask yourself if it is about single value, you use X regularly. If it is about an average, you change the standard deviation. If we were dealing with sample proportion, the condition for the central limit theorem will change to what we have done here is for sample mean. Sample proportion, we will say that for sample proportion, let X and P be a binomial distribution. Be a binomial distribution. Then X is approximately normal. And NP is greater than or equal to 5. And NQ is greater than or equal to 5. With D of X equals to NP, the standard deviation of X equals to square root of NP. Example. N equals to 300, E equals to 0.32. Find the probability that 98 is less than or equal to X less than or equal to 112. So if you have this question, how are you going to do it? So let me put it this way, and you will see the difference. There is time we can keep manipulating that inequality. So you will observe the probability of 98 less than X less than or equal to 112 is probability of 99 plus probability of 100 plus probability of 112. If I have put an equality here, then I will start with 90, probability of 98 and so on. So probability of 112 is probability of 0 plus probability of 1 plus probability of 1, 1, 1 plus probability of 1, 2. So you can see that this probability is all of this minus the probability at 98. Probability at 98 is probability of 0 plus probability of 1 plus probability of 98. So the probability that 98 is less than x less than or equals to 112 is equal to the cumulative probability distribution at 112 minus the cumulative probability distribution at 98. This is just an expression for our understanding for now. Cumulative at 112 means sum until 112, sum until 98. So you can use your calculator to do this. Remember, the probability of success is 0.32. So using your calculator, what is the binomial CDF of 112? Which is, you can write it as n equal to 300, p equal to 0.33. Binomial CDF 300, 0.33. I'll pick one calculator here. So the probability of success is 0.30. Number of trial is 300. Number of success, let's start with 112. So if somebody is doing it, you should get 0.095. 0.095 is for 1. Now what about for 98? I'm using this, I'll go and change this to 98. Cumulative 98 is cumulative 98 is 478. You have that. It was 0.95, right? Yeah. Then the probability of 98 less than x less than or equals to 112 will be 0.95. I want you to see the reason why I put this one is because I want 98. If there was equality, I would do minus 97. If it was like this, I would instead put 97 here. That's just what it is. So what is this equal to? What is 0.95 minus 0.47? Now, let's do something else. Not because it's up to 5. Let's do something else. What is the mean? The mean is NPQ. NP, I'm sorry, which is 300 times 0.33. What is 300 times 0.33? It should be 99. This is the mean. And the standard deviation, NPQ, which is 99 times Q is 0.67. This is about 0.6, maybe 66. 99 times 0.67. This is sigma squared. 99 times 0.67. This should be like 66 or 67. Anyway, 66.3. So the standard deviation will be square root of 66. Hmm? 8.14. So now, let's use normal CDF for 98. 98, 112, 99, 8.1. Normal CDF. Look at our answer here. Look at this one. They are not too different. But now let's do this. Normal CDF, 98.5, 112.5, 99, 8.14. Look at how close it is to this. So what I have done here is what is called a correction for continuity. This correction for continuity, how does it work? You look at the correction of continuity, the correction for continuity, because we are having a discrete distribution and we are using a normal distribution to work on it. So, the correction for continuity consists of adding or subtracting half the unit to boundaries while maintaining the same event. I'll give example. Example, I have here probability of 98 less than x less than or equal to 112. Correction for continuity. I will think these numbers, these events are what? 99, 100, 1 and 1 up to 1 and 12. If I add 98.5 here, I still start at 99. But if I subtract 0.5 from here, I will be adding 98 in it. So I will choose to add 0.5. That is why I will write 98. If I subtract 0.5 from here, it will be 111.5. I'll exclude 1112. So I should add 1112.5, and I still have the same event. So this should be enough. Each time you see it, if I had 98 less than or equal to x less than 1112, I will subtract here to have 97.5 less than x less than 11.5. Because if I add, I will get the 98, which is part of it, out. If I add here, I will get, if I add to 112.5, 112.5 gets in, meanwhile it's not supposed to be. So each time you're using that normal distribution in place of binomial, think about doing that correction. But I put it as optional because you have calculators that can help you to do any binomial distribution equation. But you will be doing it that way, doing one side, doing the other side, and all that. But if you want to use the normal distribution about it, you should compute the mean and the standard deviation, then adjust the boundaries. So we are done with chapter 6. Our exam will be on the 13th. Is that okay? Or would you like to do it earlier? Today is first, so we have 12 more days. If you want to do it earlier, we can do it on Thursday. But I'm thinking that on Tuesday, we can go over chapter 4 and 5 again because exam will be on chapter 4, 5, and 6. So I'm planning that on Tuesday, we go over chapter 4 and 5. Come with homework. We will do the take-home problems, and we will, review completely chapter 4 and 5. And on Thursday, we will review chapter 6. So your take-home problem and homework for chapter 6 will be due on Wednesday, not Thursday, so that we go over it on Thursday. Okay. So if you really want to submit late, you should submit before class. I would say you should submit before noon. Latest noon on Thursday, but I put it Wednesday at 11:59 p.m. So, and then we will start chapter 7, which is not going to be on the exam because we don't want to spend so much time not moving. But exam will be the following Tuesday, not Thursday. Exam will be on Tuesday, the 13th. Okay, let me quickly check the attendance.